that we have Dr. Peter Bay with us this morning, this evening. Peter is a coastal ecologist and botanist specializing in conservation and management of vegetation in coastal ecosystems. He has worked with the Army Corps of Engineers as a scientist. He's worked with the U.S. Fish and Wildlife Service and is now an independent consultant. I took a look on the internet for various projects that Peter has been involved in, and I discovered it would be actually, I think, easier to enumerate the wetland projects in Marin County that he has not been involved in, because it looks like he's been involved in virtually all of the ones, at least that I'm aware of. These include Botham Marsh, McGinnis Marsh, Bolinas Lagoon, Bahia Wetland Restoration, Aramburu Island, Lawson's Landing, and I probably have missed some. But the point is that we have with us tonight probably California's foremost expert on the plant life of our local estuaries. And it is with great pleasure that we turn to Peter. He's going to talk about the resiliency of the native plant species in Marin's tidal marshes and shorelines, how tidal restoration designed to prevent flooding will affect plants, and the strategies for conserving local plant diversity while still mitigating sea level rise. So with great pleasure, I turn it over to you, Peter.
Thanks. Just to test, everyone can hear me okay?
Yes.
All right. Well, the title of my talk is a deliberate pun. The reference to marginal survival isn't just about plants hanging by a thread. It really is about the landward edges and the seaward edges, the margins of tidal marshes, as the core of the conservation strategy needed to cope with accelerated sea level rise and climate change. And it's a different message from the traditional conservation message of emphasizing more and more tidal restoration of diked baylands, where you take a subsided dike bayland and you breach it or fill it with dredge sediment to accelerate the marsh elevations or mudflat elevations until they can become colonized with vegetation, and you don't worry about the edges. That was the emphasis in the 1970s, 80s, and through the 90s, during a period when sea level rise was understood to exist, but it was not a primary design constraint, and it wasn't a primary threat. And the title slide photos show two contrasting landscapes that illustrate this. One is China Camp at the left side. That is a view of the back of the tidal marsh at Back Ranch Meadows in China Camp State Park, also in the National Estuary Reserve. And this is a natural tidal marsh edge that represents both typical Marin natural conditions, historical and prehistoric conditions, where there's a juxtaposition of hill slopes directly contacting the backs of tidal marshes, as well as valleys, lowland flats that occur between hill slopes. So there are two kinds of topography, and one of the main messages of tonight's talk is that topography is fate with regard to marsh resilience in the face of highly accelerated sea level rise. And I'll show you more slides about this and how it works and why it's important. On the right side is where we have been with tidal marsh restoration for the last 40 or so years. This is a sort of skewed view of Muzzy Marsh near the Marta's Marsh border. This is one of the first tidal marsh restoration projects in San Francisco Bay. It is a dredge material fill marsh. And as you can see, during a perigee high tide or king tide, the edges are very, very narrow. And there is really nothing but a sort of detached floating marsh plain pasted against levees or channels. There is no place for this marsh to go but up. and going up or accreting in pace with accelerated sea level rise in a period of increasing sediment deficits in the bay, and this is bay wide, is getting harder and harder to do. And I won't bore you with a lot of models because they're not my primary expertise, but there's a lot of uncertainty about sediment availability and the ability in different parts of the bay for restoration projects that began in subsided diked baylands to not only accrete to become high marsh plains that support all the diversity you want for both wildlife and plants, but to also maintain those upper intertidal elevations that are so important to diversity. What happens if you plan only for tidal marsh platforms or plains is you get a very narrow fringe of high marsh hugging the edge of a 3-to-1 levee, or worst case scenario, an armored rip-wrapped shoreline if there's a threat of erosion and it's a risk of flood control, for flood control. So there is the briefest reduction of the gist of my message in 2 photos, and now I'll expand it probably at excessive length as usual, going into some of the botany first, so I don't lose you all to abstractions about sea level rise and keep you on familiar ground. A lot of older texts about San Francisco Bay suggest that tidal marshes, particularly salt marshes, are low in diversity. And these are generally written by restorationists or wildlife biologists who don't really probe tidal marshes with a lot of scrutiny. And John Howell from California Academy of Scientists, back in 1949 in Marin Flora, I think set the record straight because he, of course, went through not only dozens of field sites all over the Marin Baylands in San Francisco Bay and West Marin. And, he was a belly botanist. He was on the ground scouring through the full diversity of tidal marshes before the post-World War II reclamation eliminated much of what we are left with today. But he also went through all of Cal Academy's collections going back to the mid-19th century. And his conclusion, of course, is that there's a great deal of diversity in the apparently homogeneous tidal marshes. There are a few dominants in the marsh plain. They can appear to be low diversity, but if you get down close to the ground and you examine the edges, particularly where there are brackish marsh gradients, where freshwater streams or seeps or springs intersect with the backs of tidal marshes, species diversity radically increases. Any connection to terrestrial habitats such as valley lowlands or even hill slope toes, which sometimes have emergent groundwater as well, that can affect the local salinity gradients at a small scale. Again, diversity really increases. Furthermore, Howell was very prescient about noticing the small but important differences between the floristic diversity of West Marin marshes, Tomales Bay, Drake's Estero, and Limantour Estero, Bolinas Lagoon, and the interior San Francisco Bay marshes. There is a partitioning of diversity. They share a lot of species, but there are some species they do not share, and probably for good environmental and biogeographic reasons. So I just wanted this to be a dense slide for you to look at while I ramble. These are just a selection of some of the species that are in tidal salt and brackish marshes in Marin County, either historically or today, that we don't normally see in accounts of tidal marshes, and they're almost never included in the goals to conserve or restore because they're either obscure or unfamiliar or simply overlooked. Some of the diversity that probably is deserving of conservation before we lose more of it is at the species level with regionally rare plants, but some of it is actually at a genetic level within species. So the first column I'm showing here are brackish marsh species that are more associated with Sassoon marsh or Napa marsh or northern Petaluma marsh, but actually also occur locally at small brackish marsh ecotones or transition zones in parts of Marin as well. And some of them are unexpected. Some are specific to the Arid coast, like Cicuta douglasii, which I'll show you a slide of later, possibly Cicada bolanderi, but that is a taxonomic question. These are the water hemlocks. They're found in Pacific Northwest tidal marshes and Northern California tidal marshes. They were here in West Marin. They're still here. Hilianthus Californicus, which is our California sunflower, common in parts of Sassoon Marsh. Historically, it was also in parts of, I believe, Puerto Madera, within tidal reaches of riparian areas. There's a longer list. I shouldn't go through all the species here, but there is more variation in if you consider both salt marsh ecotypes or genetic variants of salt tolerant and wetland tolerant species, of wide-ranging species that occur in other environments. And we also have species that are specific to the lowland terrestrial edges of tidal marshes that don't really occur in the tidal marsh platform or plain that's composed purely of tidal sediment, but they occur in the infrequently flooded areas above normal spring tides that do get flooded regularly at an annual basis by the highest tides, the perigee tides, and usually on terrestrial or terrigenous substrates, flood deposits from alluvial fans, flood deposits from splays of streams, or eroded hill slope material, not tidal marsh sediments. These often have a specialized subflora that Howell was very aware of. I'll move on to another slide. Some of the risks for the plant diversity we have, if you account for it, and not just repeat the usual list of the top 10 species we find most commonly, are shared within the different categories of species that give us the full diversity of plant species in marine tidal marshes. For regionally rare species, I'll give examples in the next slides. The biggest risk, of course, is local extirpation. They are species of limited distribution. They only occur in so many colonies, and many of their marshes are at risk of either erosion or submergence by sea level rise, conversion to lower marsh, cordgrass marsh, or monotonous pickleweed marshes that are frequently flooded and exclude a lot of the species that depend on the highest intertidal elevations. In some cases, loss of population stability by losing the core populations, the ones that repopulate the smaller peripheral colonies after disturbances or severe climate events like extreme droughts, which cause marshes to become hypersaline, something I'll also cover in a later slide. Other risks to diversity include geographic range contraction. We've already seen that. I'll give an example with the salt marsh bird's beaks, where their type locality where they were most abundant, San Francisco Bay, is now effectively extirpated except for Marin County. And the core populations are now found only northward. Loss of genetic diversity of species is a significant risk by reducing the distribution of species and their contact with different environments. So the more we simplify or homogenize restored tidal marshes, or the more we simplify and homogenize our existing tidal marshes, the less environmental variation we're leaving to support locally adapted differentiation of populations. For wide-ranging species, some of the risks are the same. And for native vegetation, there are similar risks. There are also larger risks for native vegetation because some diversity occurs at the community level, and some forms of ecosystem resilience or stability derives from the interactions of species. For example, some species can adjust for the declines of other species and maintain marsh stability. Typical example would be during droughts, more salt-sensitive species decline. They take refuge in low salinity areas, and then they re-expand in wetter periods. And their space in the community may be taken over by more tolerant species. So the community level stability overall may be greater. The more marshes become simplified, lower in diversity, the less they're able to shift without large disturbances, sometimes leaving open options for reduced competition and invasion by non-native species. One of the most important legacies we have are This goes contrary to wildlife-centered concepts of what conservation priorities should be. We have good reason to conserve large tidal marshes for wildlife. There are minimum requirements for home ranges and foraging, but for plants, some of the smallest remnants may be really important refugia for species that are hanging on to very edaphically defined subhabitats, things that are literally in the rocks or in the soils or the geomorphology and can't be moved somewhere else. Sometimes it's something as simple as an interaction between local hydrology, like a freshwater seep, and a particular kind of substrate, like sand from an old landslide or an old flood deposit. That intersection of variables may provide unique locations for populations of plants that otherwise would have a difficult time competing in other environments or persisting through disturbances. So there are different levels of diversity we need to conserve, ranging from community level to conserving wide-ranging species and the diversity they bring to regional marshes, and as well as the traditional rare plant diversity. And now, to give you a break from abstraction, here is one of the emblematic species of one of my favorite species to work on conserving is, I'll just refer to it generally as a salt marsh bird's beak. This is now Chloropyron maritimum. There's a closely related subspecies in Southern California. Usually it doesn't have as much pink or purple as this one. The two southern and northern subspecies have probably been separated for most of the late Holocene. It's very likely that at lower sea levels, there was a much more continuous population among closely spaced marshes at lower sea level in the post-glacial period. And these were separated by rising seas. Sea level rose about 400 feet in the last 10,000 years. So that's a lot of separation by drowning out intermediate habitat. So we were left with the northern end of that population of what was probably a continuous chloropyron population. And San Francisco Bay was the largest population in early historic times, at least the largest that was known by Hans Baer, who was the first botanist at California Academy, who named it. It is virtually extinct in San Francisco Bay. Marin represents, as I mentioned, its last stand in Richardson Bay. The species' core populations are now distributed northward in Tomales Bay, Bolinas Lagoon, Drake's and Limitor estero. It is a very abundant species, but like many annual species, just like vernal pools, they can go through boom and bust cycles. So they can appear to be virtually extirpated for years in a row. And I won't go into the environmental factors because they're not well understood, but they do have big boom years, and they can actually be dominant species or co-dominant species in extensive areas of marsh, just like salt marsh dodder, a parasitic plant, could go from virtually absent to one of the dominant covers in late summer. This is a remarkable annual species. It's a hemiparasite. It unlike a full parasite that taps hosts for both nutrients and metabolites, sugars, this one just taps its perennial neighbors for water. So it can often grow in marshes that are too saline or too harsh for other species that are depending entirely on their own roots. So it will actually tap pickleweed and other broadleaf plants. One of the largest remaining populations is in Bethune Marsh in Richardson Bay, and there are a number of other subpopulations ranging from Greenbrae at the Greenbrae Boardwalk, Hirt Marsh, and a few other smaller, more tenuous populations between Greenbrae and Bethune Marsh. I'll bring this up to the Marin chapter because its vernacular name is currently Point Reyes bird's beak. It's been that way for about 30 years. I just point out that the type locality is San Francisco Bay, and I believe the premise was that it was rediscovered in Point Reyes. Actually, John Howell recorded the localities in Point Reyes and Tomales Bay in the late 40s, and they've never gone away. So it has probably been in West Marin throughout the late Holocene, but it's also been in San Francisco Bay and other places for the late Holocene. So it probably is better understood as the northern salt marsh bird's beak, as opposed to specifically Point Reyes bird's beak. But the name is going to be on the books for a while. It has other kinds of diversity than just its being rare. One thing that a lot of botanists who are very interested in the genus have found is that there are at least 2 floral morphs, and this is not part of the taxonomy, but the San Francisco Bay populations all have an exserted corolla, bright pink tip, with an inflated pouch. And that is, these are the ones that are associated with native bee pollination, solitary bees that move into the salt marshes, often working gum plants and other conspicuous flowers. They will actually cross-pollinate the exserted flowers with the inflated pouches. There's another form that looks like it might just be an unopened or immature form, but they actually seem to have a different morph where it's a tubular corolla and they are barely exserted from the flowers. And it's suspected that these are cleistogamous or self-pollinating floral morphs. So there may be different breeding systems available. Having enforced self-pollination is a good way to ensure that you get seed production regardless of pollinator availability. Hasn't been studied. But there does seem to be a difference in the variability between the West Marin and San Francisco Bay population. So an important, it's not enough to just say, well, we've got it at Point Reyes. We don't need to have it in other places. There's probably among population variability that's important for the long-term evolution and conservation of the species. Sorry about the dog. This is a telling tale about the difficulty and opportunities of conserving rare plants in an urban estuary. Chloropyrin marinum was present in Richardson Bay all through the 1940s, 50s, and 60s. It was in great decline. When I started looking at the marshes there in the early 90s after the drought, it was almost nowhere to be found. But one location at a site where there was a violation, a fill violation in a salt marsh, was enforced by BCDC. BCDC ordered the removal of the fill. The fill removal was incomplete and it left terrestrial soil fill at slightly higher than marsh elevations. They didn't quite get it right. But that opportunity created a blank slate for sparse high marsh. And by the early 1990s, that incomplete fill removal, the off-spec fill removal, exploded with the largest single population in San Francisco Bay, which is still there. This is behind Glassdoor, the end of Pahono Street, next to that kind of junky yard, I don't remember the name of it. And it has been a seed source that actually repopulated, I believe, in Marsh. The Marsh's population was down to just a few plants by that time in the early 90s. So this kind of illustrates the erratic nature and the idiosyncratic nature of localities. No one would ever consider this to be an important salt marsh or a high quality salt marsh. That was, it was of outsized importance for the long-term conservation, the erratic conservation of the Athene Marsh and Richardson Bay population of birdsbeak. So little anecdote there. The range of this northern subspecies is probably San Francisco Bay North, but I just wanted to point out that there is an intermediate population in Morro Bay that people have gone back and forth about, arguing which subspecies it is. And that's probably because it is intermediate. Another species, also in the Orobanchaceae, formerly the Scrofulary ace, similar ecology, but not identical to chloropyrin. Chloropyrin is a salt marsh obligate, occurs only in tidal marshes. Castanea ambigua may be a hodgepodge of cryptic taxa. I'll just speculate about that. And there's some evidence of that too with some taxonomic studies that David Tank is conducting. We have 2 named taxa. I absolutely believe in one. I'm not sure about the other. Castanea ambigua humboldtiensis, Humboldt Bay owl's clover, has its southernmost population in Tomales Bay. It's atypical. A lot of the flowers, the bracts are pure white and only get a little tinge of purple, which is the diagnostic character for the subspecies. very late in development. Otherwise, they're kind of white and very similar to a widespread form that occurs in Oregon. But probably this is the southern extent of the Humboldt Bay population, which actually comes here into Mendocino coast. I found a large population just recently exploded in the Garcia River estuary. But Tomales Bay is its southern limit, and it's a succulent plant, has a very distinct ecological niche, a little lower and wetter in brackish marshes. The more typical subspecies, Ambigua, has salt marsh ecotypes as well as upland terrestrial vernal pool ecotypes and dune ecotypes. Again, it seems to have a huge ecological amplitude, and there are morphological variants that seem to correlate with the differing geographic positions and ecologies of the populations. But the salt marsh populations are more widespread. They historically occurred in San Francisco Bay. As far as I know, this is extirpated in Marin Baylands in San Francisco Bay. A small population persists in Rodeo Lagoon. There are extensive populations in Bolinas Lagoon near Kent Island and also near Pine Gulch Creek. And I could go on. It kind of drops off at Tomales Bay, and it's replaced north of Tomales Bay by these other subspecies, Humboldtiensis. And they both occur together and possibly hybridize in Tomales Bay. So this is also emblematic of a formerly abundant species that's now reduced its range to West Marin, extirpated in San Francisco Bay, and still occurs with genetically complex populations with different subspecies in some parts of its range. I would like to go back also to point out that like vernal pool wildflowers that have those boom and bust cycles, both Castanea ambigua and chloropyrin go from extremely sparse populations to co-dominant or superabundant populations. And the name chloropyrin literally means green fire. And I think it may be like the word agropyrin, the genus agropyrin, fire of fields. It's a very aggressive weed. It takes over fields. I suspect that Hans Baer, who named the genus originally chloropyrin, recognized that these salt marsh annuals could actually dominate and take over very rapidly extensive areas of salt marsh. There are some descriptions that suggest that. Other forms of diversity are associated with brackish marsh ecotones or local brackish marshes. This is an example of, I'm going to put this one as Cicada douglasii, although there's some question about whether it may be Cicada bollanderi, which was previously interpreted to be endemic to Sassoon Marsh. I do know the Sassoon Marsh populations, and this one to me has more agreement of characters with the North Coast douglasii populations. These are found around Point Reyes National Seashore and Drake's Estero and a few other places. Very localized populations, usually in association with brackish seeps, freshwater seasonal stream mouths that modify the edges of fully tidal salt marshes. Highly toxic plant, and the genus is much reduced in the San Francisco estuary. Another relatively rare plant, representing, like Cicada douglasii, the southern limit or near the southern limit of its range, is a salt marsh dominant, a tidal marsh dominant species that ranges from Alaska to Mendocino County. It actually is the equivalent of cordgrass for North Coast and Pacific Northwest estuaries. This is Carex lingbii sedge, and it forms large fringing low marshes in fluctuating brackish estuaries, mostly in river mouths. But there is an outlier population in the recently restored Outer Jackamini Marsh in Lagunitas Creek Delta. And it's probably just hanging on. I'm not sure it's going to make it through some of these droughts that have caused, spikes in salinity. It may persist. It's possible there are other populations in Tomales Bay that are hanging on somewhere. It's an inconspicuous plant when it's not in flower, very hard to identify. And it probably manifests more during pluvial periods, periods of higher rainfall. So this is something we're probably always going to be at the cusp of losing at the southern limit of its range, particularly as climate warming increases the duration and intensity of droughts. Getting down to the bottom of my representative list, this is one of my favorite tidal marsh species. It's not exclusively found in tidal marshes, but is also associated with very low coastal bluffs with seeps, some dune slacks. This is Astragalus pycnostachius, variety of pycnostachius, coastal marsh milk vetch. It is very narrowly distributed. It occurs in Point Reyes, in Drake's and Limentura steros, but apparently not in Tomales Bay, and there's no record of it ever having been in Tomales Bay, even though it's a very short dispersal distance away. This is hanging by a thread. This is all literally marginal in the other sense. It grows in sandy edges or bluff edges of tidal marshes, which I'll bring this point up again towards the end about conservation strategies. During droughts, the free roaming cattle of Point Reyes tend to congregate where it's greenest, which is usually by the water's edge when the hills dry up, and they trample through the subhabitats of Astragalus very intensively in search of other species. Marsh local wheat is highly toxic. They don't graze this plant at all, but it gets battered pretty badly and loses a lot of its reproductive capacity as cattle are in search of other edible, palatable species. It has, fortunately, highly persistent seed banks, so we're not in an imminent danger of losing it, but populations do wink out. There's at least one I'll show you that may have been lost, and its long-term conservation will depend on maintaining very specific edges in conjunction with those persistent seed banks. Okay. The last kind of diversity is not species-based, but ecotype-based, or broadly, I don't mean to be too literal about ecotypes, but locally adapted populations that are genetically differentiated. Ecotype is one way of categorizing that, but ecologically wide-ranging species with wide ecological amplitudes, like common yarrow, Achillea millefolium. There are robust, tall, dune-adapted types you can see in Point Reyes. Some of them get almost 1.5 meters tall in Morro Bay. And there are totally different wetland-adapted ecotypes that grow in pickleweed marsh, low salinity pickleweed marsh, mind you, in Petaluma Marsh and also in Martinez and Sassoon, that spend their entire life cycles in brackish tidal marshes. And they actually form carpets. They are not just peripheral high marsh species. They're actually out in the marsh plain. Similarly, a widespread maritime coastal plant from West Marin tidal marshes, Festuca rubra, actually occurs in really local marsh edges in tidal marshes like China Camp, some old growth tidal marshes, and even in parts of Sassoon Marsh near Benicia. So these are small contributions to diversity. They're kind of off-brand. No one usually lists these as the mainstays of tidal marsh floras in San Francisco Bay, but they are integral to it. And you can find that this is borne out in historical records. We just sort of, it's almost like punishing them because they've become rare and inconspicuous. We don't include them in our restoration and conservation objectives because we never see them, but they are out there and they were there. And the decades ahead with increasing environmental stresses from climate change will probably be a bottleneck for them. They may need special attention. So backing up a bit, where does if we're trying to get the bang for our buck for marsh management and restoration in Marin, where does most of the important tidal marsh plant diversity occur? It's not uniformly distributed. The lower in the intertidal zone you go, the fewer species dominate, and the fewer species compose the community. We all know that below mean high water, almost the only species we see in regularly flooded, fully tidal salt marshes are cordgrass and some of the annual pickleweeds, and occasionally other species, but it's down to one dominant species and very few others once you go below mean high water. The higher above mean high water, average sea level you go, the more species richness and the more species diversity you'll find. So to summarize, the highest intertidal zones and their terrestrial transition zones pack in the highest species diversity and probably also the highest infraspecific diversity within species diversity, like ecologically differentiated populations, particularly where the substrates are not uniform bay mud, but they include diverse substrates from stream channels or landslides, colluvium, or hill slope eroded edges. That substrate diversity is really important for packing in those extra salt marsh species that are still found below the highest tide lines. That's my working definition of tidal marsh, below the highest tides. The other hot spots or hot zones for tidal marsh diversity in Marin and elsewhere are brackish tidal marsh gradients, areas where the maximum salinity in the year is subdued or buffered, and where the average salinity is well below marine salinity, about 35 parts per thousand. So good examples of that are, of course, in the back of China Camp Marsh, which is one of the only intact tidal marshes that still has all of its hydrologic and topographic connections to terrestrial habitats. And that's one reason why it holds diversity that we have lost in many of our diked and restored marshes, which tend to select for a handful of widespread, fast colonizing species that are relatively indifferent to substrate and variations in salinity. And the other main refuge for tidal marsh diversity, and this does not have to be with large marshes, this can also occur in very small remnant spots, I want to emphasize that, is that older, that is early historic or prehistoric tidal marsh remnants, especially those that have contacts with terrestrial or fluvial sediments, hold a lot of species richness. Often it's remnant, it's held over from previous epochs or different earlier sea levels or different climate periods. They're hanging on by threads and often in very small areas, but they're persistent. So we have our flagship marsh, China Camp Marsh again. Everyone knows that one, but there are also smaller remnants, some very inconspicuous. Very few people, I think, know that the Alto Marsh was named by USGS scientist in Mill Valley, the whole patch of marsh just south of the sewage treatment plant. That is a prehistoric marsh, just like the Greenbrae Marsh remnant or Heard Marsh in Puerto Madera. That's a prehistoric remnant, and not coincidentally, it has salt marsh birdsbeak. Petaluma Marsh, of course, is the largest prehistoric marsh remnant in the entire estuary, and it houses exceptional diversity, which is undersurveyed, partly because of access. And in the West Marin marshes, one of the old early 20th century washovers from large storm events that became fallow or stable for many decades, Lemontour Spit, that is a very old tidal marsh, and its species diversity vastly exceeds equivalent areas of younger tidal marshes, which are widely distributed in West Marin. Here is an example of one of the high marsh ecotones that is not formed by tidal marsh processes such as tidal sedimentation. This is a wave deposited, basically it's a beach of coarse sand and gravel. It forms a high marsh berm. You can see gum plant dominating the top. This is a former locality of Astragalus pycnostachius, apparently extirpated now. Waves and flood events from either the shoreline or from hill slopes can raise topographic elevations and sediments above the tidal frame and by gradients that tides alone can't produce. You can see the flat marsh, that's a high marsh behind it, but it's completely flat with very, very subtle topographic and drainage variations along channels, but they're only on the order of a few centimeters. waves can wash sediments well above the still water level of tides, creates a very distinct topographic and substrate gradient. Similarly, alluvial fans can do the same thing. And these are often associated with particular species that take refuge. Here's an example of one of the most important ecotones or transition zones that are rarely, if ever, captured or replicated in tidal marsh restoration projects. And they also support communities that are not arbitrary assemblages of, upland species that happen to hold the soil or grow in graded random levee fill, but these are alluvial grasslands or wet meadows, lowland or alluvial grasslands, not just generic valley grasslands that grade very gently down into tidal salt marshes. This particular stand is dominated by a combination of Baltic rush, Juncus balticus, also Juncus arcticus, and creeping wild rye, which is one of the most ubiquitous species in tidal marsh edges. It almost deserves to be considered its own transition zone dominant vegetation type, because you can find it in Martinez and in Sassoon and in the outer coast. It is almost ubiquitous, and it can be replaced by closely related species and hybrids. This is one of the typical ecotones and transition zones of valley grasslands and tidal salt marshes. Here's another phase of it. This one's dominated a bit more by Juncus balticus. You can also see some Juncus patens clumps in the edges. Notice that edges, unlike levees, are not dominated by tall shrubs. There are shrubs that move into graded levees, and sometimes after cattle, you can get a kind of an invasion of coyote brush, but the natural assemblages tend to be these clonal perennial grasses, grass-like plants and forbs at the edges of valley grasslands grading into tidal marshes. And finally, this is back ranch meadows again at China Camp. And here we just see the pickleweed at one edge. You're really at the extreme upper limit of the highest tides. This is a lush stand of Carex praegracilis. People don't often consider it a salt marsh plant, but it definitely grows in the upper intertidal zone, where it intergrades with these riparian or alluvial grassland elements with tidal marsh. And to have this kind of diverse tidal marsh edge assemblage, you have to have hydrologic connectivity with alluvial lowlands, very gentle slopes open to the bay. And that, of course, we have very rarely anywhere but Sassoon Marsh and only a few places there, and in parts of the North Bay. China Camp is an exception, but this represents one of the dominant landforms of tidal marsh edges that house some of the original diversity. And another element that goes with that very gently sloping topography of alluvial lowlands is that hydrologic connectivity. If you add freshwater seeps or seasonal streams or perennial streams to the back of a tidal marsh, you'll create a fluctuating zone of freshwater riparian, freshwater marsh to brackish marsh. These wax and wane through precipitation cycles. Salt marsh species advance in when they're in decline from excessive salinity during the droughts, when their springs and seeps dry up. The gaps left behind allow some species to grow that are outcompeted when they're nice and predominantly freshwater or predominantly saltwater. So there's some diversity in the gaps during the transitions in these climate swings. So having these fluctuating gradients built into the backs of tidal marshes provides diversity of habitat, which then provides for diversity of species and also ecotypes. And it also provides for floristic diversity. We've kind of partitioned the bay into different sub-bays where we think there's a distinct flora for Sassoon Marsh, and there's a distinct flora for San Pablo Bay and another one for South Bay. We have homogenized those floras by making them more extreme and limiting the diversity of the marsh. I'm getting a signal my internet connection is unstable, so if something is going on, please let me know. But in fact, historic localities and remnant localities today show that a lot of the Sassoon marsh flora was patchily distributed, not only in Marin, but in parts of the East Bay and even the South Bay. And this is a long list. You might want, if you want a copy of the slide presentation later, to look over. But a lot of typical Sassoon marsh species do occur or did occur historically. I'm not so sure about Glock's Marina, Lysimachia Marina now, in Marin Baylands and in some of the Brackish marshes in Point Reyes as well. So again, the importance of maintaining hydrologic connections to terrestrial and fluvial environments is really essential to maintaining that community level diversity in tidal marshes. Another benefit of connecting upland or fluvial hydrologic connectivity to tidal marshes is the resilience you get by buffering extremes of salinity. During extreme droughts, average summer peak salinities in salt marshes becomes double or marine salinity, and very few species can tolerate double or triple ocean salinity, except for pickleweed. So our marshes do become very monotonously dominated by pickleweed during droughts. But these brackish buffered edges, they don't thrive during droughts, but they can provide reduced extremes where some of the more diverse salt marsh floras can take refuge and maintain reproductively viable populations in proximity to these brackish transition zones. This is a single canyon stream at the back of the south end of China Camp Marsh. It actually has most of the dominance of typical Sassoon marshes, Spiniflectus acutus, Bulboscinus acutus of alkali bulrush, tules. But during droughts, this is where some of the only flowering populations of gum plant can survive. The gum plants out in the tidal salt marsh during extreme droughts where the marsh gets hypersaline, they just fry, and they certainly can't flower and produce viable seed. But in the vicinity of some of these brackish edges, they can make it. Another example of one of the most scarce types of ecotones in San Francisco Bay is found in the north end of Bolinas Lagoon at Pine Gulch Creek, where one of the distributary arms of the large Pine Gulch Creek Delta maintains an active deltaic lobe in the tidal marsh. And you can see there's cattails and tules and very robust forms of Juncus lascurii, salt rush, that form very intense local freshwater to brackish gradients, as well as disturbances from sediment deposition from flood pulses. Those are actually stream gravels, as well as sands deposited right in the tidal marshes. This maintains a lot of diversity of perennial species that are tolerant of burial, sediment burial, and tolerant of fluctuating salinity. Not such a great refuge for annual salt marsh plants like bird's beak or the castelleas, the owl's clovers, because their seeds get buried in sediment, and so it tends to exclude the annual forbs and maintains another kind of diversity. The annual forbs on these deltas actually are better at occupying the inactive lobes, the relict lobes or distributaries of the delta that are abandoned and go fallow for decades. Those become excellent areas for colonization of some of the less common annual forbs. So diversity even within deltas, rather than a homogenized kind of connection. All right. Now back to the abstract and sea level rise. How have tidal marshes maintained themselves or evolved through past sea levels? This is really important because we're entering a period now that is likely to bring sea level rise rates that we have not seen, that we never have seen, not Europeans anyway, that have not been here since the mid-Holocene. And the early Holocene, that is the post-glacial period when glaciers were rapidly wasting and filling the oceans up rapidly, there was about 300 to 400 foot rise in sea level in the space of a few thousand years. And sea level rise rates were on the order of 9 millimeters a year, almost 10 times what they had been in the last century. And we don't have records, stratigraphic records, sediment core records of salt marshes from that period. Some of them may be, abandoned offshore, far outside. I mean, San Francisco Bay didn't actually form. The bay edge was around Hunter's Point in San Francisco about 8,000 years ago. So it didn't really invade Marin until after 6,000 years. And about that time, sea level began to slow down. But San Francisco Bay tidal marshes, as we know them now, didn't begin to form until about 4,000 years ago, and then only mostly in the North Bay. Without getting too pedantic about this, the main point is that the tidal marsh systems that we've come to value, the ones that we've used as models for our restoration template back in the Goals Project days in the 1990s, that was based on a 19th century snapshot of the bay. And we kind of looked at it the way we did old growth forests. It's been kind of there eternally. Well, we now know that is absolutely not the case. Sediment cores with pollen stratigraphy, looking at ancient pollens, looking at proxies for past salinities and different sediment types, have shown us that the bay went through a period of rapid accretion, of sediment accretion, and it didn't get capped by peaty salt marshes until very recently. And even during that early period of formation, the marshes were very unstable. They kept reverting to mudflats, and then they'd start as another kind of tidal marsh. Some of them started in dry, multi-century droughts as salt marshes up in Sassoon. And then they'd founder and become mudflats again, and they'd come back as brackish marshes. So there's a lot of instability to the marshes that we thought were kind of immutable and locally adapted. Recently, there's evidence that most of the South Bay and possibly the Central Bay as well, the 19th century maps were representative of a very brief period of rapid aggradation of the bay from the Little Ice Ages, when there was intensive precipitation and massive mega floods, some of them preserved as little sand layers in the cores at China Camp from alluvial fans that were flushed way, way out in the tidal marshes. They've left little traces. So these idealized stable marshes, marsh platforms we've been trying to restore, they are not geologically stable or old. They are legacies of a particular phase of climate. And the most important thing I'd like to impress on you is that they formed almost exclusively during some of the slowest rates of sea level rise in the last 10,000 years. And we're not going back there. It doesn't mean that tidal marshes don't form under, more rapid rates of rise. They may, but most of what we inherited, we've used as our goals for restoration, really was very specific outcome of a particular phase of our climate and sea level rise history. And that's a new story. That's relatively new. This is for those who want copies of the presentation. If you want to delve into the background, the Malamud Rome et al. Paper, Holocene Climates, was written for a broad audience. It is a technical paper, an excellent introduction, and some of the more earth-shaking or marsh-shaking news about the sudden expansion of the San Francisco Bay marshes by Watson, Elizabeth Watson, who's now in New England, is also listed. I really recommend those. Here's a look at some of the innards of China Camp Marsh to show, this is one of the study sites for stratigraphy of the older marshes. This came about in the 2000s. This is after the Goals Project. I'll just point to the core at the extreme left. You can see I've left in brown, gray, are clay-rich muds. Those represent mud flats graded over years. The whole length of the core is about 3,600 years. And you can see the areas that I've greened in. Those are, I'll call them marsh peats. They're more salt marsh soils, but you can see they came at different periods and they were interrupted by long intervals when there were no marshes. There were mud flats that may have been due to erosion or submergence, but a discontinuous sequence and a discontinuous core. The authors also found two other things you can see in the central columns. Those dark gray lines show different pollen abundances in the sediments. And they can only identify them to the level of family, but these species are often used as proxies for salinity. For example, the column on Cyperaceae, the sedges. Sedges are brackish plants that are not tolerant of high salinity. You can see that about 3,000 years ago, there was a big spike. That was a very wet period. And there was a long period where salinities were high, their abundances were low, and then they spiked again. That's probably the Little Ice Age, right at the upper third of the column. And that was associated with marsh building. So you can see that most of the marsh that we've inherited came from a relatively wet period interrupted by some mega droughts. So there's been instability even within those last 2,000 years. So ecologically, these tidal marshes have been a very moving target. Here's another quote from China. Here you see a switch from mostly mud flats with organic emanations to mostly peaty soils. And those little dashed lines represent strata that probably record mega floods, where the marshes were washed over by flood sediments and then regenerated. So again, a very stable climate, even during this relatively benign last 2,000 years. So how do tidal marshes persist through periods of accelerated sea level rise and more variable climate cycles than we've seen in what we imagine to be relatively benign periods, but actually last couple thousand years have been very active with climate fluctuations, mega droughts and extreme high precipitation periods. One of the most reliable and globally important ways of maintaining tidal marsh is not through vertical accretion. It's through landward marsh migration, or the jargon is estuarine transgression. And these require that sea level or the high tide line migrates over a very low gradient flat planar valley. And the important aspect of this mechanism of salt marsh persistence is that it is independent of current sediment deposition rates. It depends on topography. In other words, you can flood your way into or submerge your way into a new tidal marsh, even if there isn't a lot of sediment to move around. And this is really relevant now because globally, most of the first models about the viability of marshes under accelerated sea level rise were showing a very grim picture. They were showing that without higher than usual amounts of sediment, marshes were going to drown all over the world and there's going to be collapse. Then they recalibrated the models to include landward marsh migration, assuming that it was unimpeded. And actually, in some parts of the world, salt marshes gain. They actually expand in some models. During transgression, this of course requires getting out of the way, leaving freshwater swamps or agricultural land or other flat lands of low intensity land use to become salt marshes. That requires planning and land use changes. But I put an asterisk there because this is a geologically resilient way of forming salt marsh. It's independent of sedimentation. The other changes in horizontal dimensions of tidal marshes is potential for seaward growth or progradation, but that depends on an excess of sediment coming out of usually rivers or streams, blowing out large loads of sediment very rapidly, more rapidly than it can be removed by wave action or suspension. Basically causes prograding deltas to form in estuaries and flattens waves so they don't erode out the edges. We're not getting a whole lot of that. So that probably is something that we can look for in very local watersheds that have positive sediment budgets. There's one in San Francisco Bay that comes to mind, San Lorenzo Creek, which still has a very active wide delta over in the Hayward shoreline. I don't think we have any like that in Marin. And the other horizontal change to bear in mind is bay marsh edge erosion. That's not just Marin, but a lot of the global models and more recent evidence shows that one of the major sources of salt marsh loss is not just submergence or the internal erosion from ponds enlarging and eating out the centers of tidal marshes. It actually comes from wave attack from the outer edge. And as bays deepen with sea level rise, deeper water generally means, for a given wind speed and given distance for wind to blow, wave energy increases. So marsh edge erosion is often likely to increase with sea level rise. So there are two features to bear in mind. This is very different from the focus of traditional tidal marsh restoration. Creating marshes not by breaching, diking, de-diking, dike removal, and filling or passive sedimentation, but creating space to submerge a valley or plain. And we don't do a whole lot of that because we've been trying to fill in the 19th century templates of past tidal marshes. And I sometimes wonder whether that ship hasn't sailed, some parts of the bay at least. Vertical change, this is where all the emphasis has been for tidal marsh conservation. And that's based on sediment accretion and organic matter produced by salt marsh plants, keeping pace with sea level rise. And that was relatively efficient when we had a surplus of sediment, particularly after the gold rush. There was a lot of excess sediment in mudflats stored from the legacy of the gold rush, sloshing back and forth across the North Bay in particular, and relatively productive tidal marshes, creating organic matter. They were able to keep pace with sea level rise. That may be slipping in places. There is some evidence in Bethune Marsh that we are already starting to, this is within the last 10 years, starting to backslide or downshift marsh zones where pickleweed is starting to integrate more with cordgrass, and cordgrass is becoming more dominant as marsh topography falls slightly lower in the tidal frame. That's Elizabeth Watson's research. Generally, the models so far over like a 70-year, 2070, or actually 50 years, sorry, they're not very encouraging about, I mean, we can get near-term gains in tidal marsh accretion, but by 2070, a lot of models are, these are some of the restoration projects I'm working on, where we're looking at long-term scenarios. Things don't look very encouraging when you get past 50 years. And some of the higher rates of sea level rise start to overwhelm these basin-filled dike baylands. And that's what keeps pointing me back to the importance of landward marsh migration, because it's been the least emphasized aspect. Here's what it looks like. Here's a natural example. And I use this to, if I can burn one image of what tidal marsh natural tidal marsh transgression, estuarine transgression looks like. Here's Point Reyes National Seashore. This is an arm of Limentura Estero, I'm pretty sure. You can see there is a long stream valley. This is the drowned head of a valley. It's a very ancient Pleistocene stream valley. The original mouth is probably well below sea level now. And you can see the gray-green dendritic pattern of tidal marsh channels grading into what is riparian lowlands, alluvial grasslands, and scrub. And as sea level rises, it simply slides that tidal gradient up that valley. It's almost imperceptible. All you have to do is not put anything in the way. This is one of the alluvial drainages in Point Reyes that was not impounded by ranchers to create ponds for stock watering. So has a fairly free run here. But this is the ideal template. Of course, in the urbanized estuary, we don't have a lot of this. We did. Here's an annotated, this is actually a working drawing of my own for Bethune Marsh. I was looking at the earliest 19th century US Coast Survey maps, the T-sheets of southern Richardson Bay, to look at the distribution of tidal marshes. And I didn't draw it in here. The modern Bethune Marsh is entirely over what used to be subtidal bay and intertidal flats. There was no marsh at Bethune Marsh. The marshes naturally formed at the heads of bays. They were the upper, the lower edges of former stream valleys, but they weren't necessarily connected to streams. If you, I don't know if you can see without getting too close to your screen, but a lot of the tidal marsh sloughs kind of narrow and wind into terminal sloughs. They don't connect up with fluvial streams. So there were no direct stream supplies to most of these tidal marshes. One exception might be Gobi Creek, which is now the Arroyo near Mill Valley. But most of these were just dead ends of the heads of bays where sediment accumulated. They did not extend over broad flats like the South Bay. They were little pockets, and some of them were sheltered. I don't know if you can see, but there are little tiny barrier beaches, very much like that small sand spit I showed you from Schooner Bay that had the used to have the astragalus on it. Those were those sheltered some of these pocket marshes from the full brunt of wave energy from the bay. They were little barrier beaches. So this was what we inherited. Now we're trying to save marshes that we forced to build out in what used to be high energy tidal flats. And now we're adding sea level rise to that. So this is, I think, a hint that we need to look at moving where we have the space available, moving marshes up valleys, up lowlands, to the extent that they're not developed, and there are very few, as more defensible spaces for tidal marshes. And this is not about the long-term future. I'm going to get you back to the present. We often, the reason I didn't put any model charts up about sea level rise scenarios is that people often talk about sea level rise as though it's something that's going to happen in the future, but really hasn't happened yet. If you walk along the edges of China Camp, you will find some old cut stumps of, I guess, that were considered hazard trees, some oaks that were drowned by the high tide line, by sea level rising in historic times over these what are now the stumps of oaks. Here you can see gum plant and pickleweed surrounding a cut oak stump that's still in place. Next to it, you can see a valley oak that is now half inundated during perigee high tides. I'll run through these examples. Here's a very old valley oak at the Back Ranch Meadows in China Camp. Two things are happening here. As mean high water rises, so does the groundwater contacting the bay. The terrestrial fresh groundwater rises in concert with mean high water. So as the tides rise, the back of the marsh starts to back up emergent groundwater, and you get freshwater marsh now growing under this valley oak. The valley oak actually is submerged under about, well, during the highest perigee tides, the largest king tides, about 6 inches of seawater over most of the base of this, I'll assume, a couple 100-year-old oak. And here you can see another valley oak that is now growing in the transition zone. Notice its canopy is a little less dense than some of its neighbors. High tide line is migrating over it, and look at the size of it. It's not that old. So this sea level rise has been happening, and it's happening at an increasing pace. Here's an example of the change of pace. I'm now bringing you over to Bethune Marsh in southern Richardson Bay. The levee that used to be, the levee was enclosing what were tidal flats in the 1950s and 60s. So it encroached the mud flats. The levees were built in the 50s and 60s. And I guess some maybe progenitors of CNPS planted them with coast live oaks in the 70s, native plant gardening. Back then, they were upland habitats. They were low, and most subsidence on levees happens within about 20 years. They don't keep subsiding indefinitely. Well, the 1970s plantings of coast live oaks are, especially in the last 12 years, since 2008, have been regularly inundated by the highest tides. And actually in the last 15 years, I've watched the understories, the ground layer under all these oaks shift from predominantly terrestrial to salt marsh. I've actually watched salt marsh encroach and kill all of the oaks, which are now predominantly skeletal. This is the south levee of North Bethune Marsh. And underneath them are salt marsh dominants, saltgrass, pickleweed, gum plant, as well as ecotone species, transition zone species such as Carex praegracilis, clustered field sedge. Show you a bunch of photos of this just to really want to imprint you on this. These are substantial oaks. They're not little saplings. They have good, some of them are a foot in diameter. And in the 90s, these were all terrestrial vegetation dominated. You can see this is the Landward edge along Almonte, where there is a snag there, a dead snag. And so the drowning has happened at an accelerated and visible pace. Communities have not just gradually changed, they have switched, they have converted from ruderal and terrestrial to high salt marsh and ecotones in the last 15 years. And that's personal observation. And it has not happened continuously. The drivers of this are not the average sea level or the average high tide. It's the extreme events that occur during what we now call king tides. King tides are, you notice that the high water levels here are not associated with a storm. It's clear, warm afternoon. There's barely a ripple on the bay. This is high pressure, which should set down sea level. These are events during normal perigee spring tides and periods of elevated sea surface temperatures in the Pacific. When the Pacific sea surface temperatures are warm, water swells, and as much as a century's worth or nearly a century's worth of sea level rise can occur very abruptly in a matter of months. And you get these tides that are far above the elevation predicted for the astronomic tides because of this thermal expansion. So what you're seeing is kind of a preview of these jumps of sea level that may occur not as a smooth curve like models form, but a very jagged line like the historic records show. And it's these extreme events that are kind of like the dominant discharges of a river system. They're what set the boundary conditions for the salt marshes. These are what set the high tide lines and the communities that follow them at new elevations. And again, I've watched these levees go underwater for the first time, just like San Pedro Road and China Camp, and they will rapidly convert to a new community type. Here's the other side. This is I'll consider the benign side. No one's been managing Basin Marsh for a long time. We're getting into it now, but just as these sort of short-term planned oak plantings on uplands were not far-sighted for sea level rise, no one was planning on succession happening either. And without any planting, without any restoration plans, some of the same natural community dominance of the transition zones at China Camp, Carrot progressilis, clustered field sedge, and creeping wild rye, Linus or Elamus triticioides, which occur in small remnant populations around Richardson Bay, usually little weedy spots. They had enough seed rain into these baylands. They found these transitional habitats when they were collapsing, when the old terrestrial dominants were losing their competitive edge. They seeded in, and now you see in the foreground here a dense stand of clustered field sedge that is now moving into the salt marsh, kind of rooted in the better drained, less salty remnants of that levee. So some of that tidal marsh transgression is occurring on its own where it has room to do so, where the gradients and the soils are all right. This, I think, is something to notice. This is a cue. This is the way marshes can work. No one's filled this, no one's restored this. It's an estuarine transgression process in a microcosm. And here you can see the old community giving way to the new community. There are the old oak snags, live and green 15 years ago, and now turning into high tidal marsh transition zone. Here's how abrupt it can be. According to this is again an illustration of these abrupt, brief, intensive of predicted sea levels from these El Nino events or elevated sea surface temperatures in the Pacific, the blob, so-called blob. Department of Public Works folks in Marin that I talked to on the scene said they had never seen flooding of San Pedro Road like this. The first episodes, I think, were 2008. And I would go back pretty much whenever we had forecasts of warm Pacific sea surface temperatures on the perigee tides to start documenting these. And you can see these were eye-opening for people in Marin County planning departments, several of them, to see flooding like this occur out of nowhere with just unprecedented flooding. And on the one hand, a good part of the story is that these roads are not great impediments to salt marsh transgression. They go right up and over, they're not barriers. They slow the drainage a bit. But it shows you that these are erratic and unsteady rates of climate change drivers. It's not a smooth curve that happens only as in the future as a challenge. It happens now. There's that's Christina Thoms from the Water Board. I think she spoke to you recently, or spoke to your board recently, and Jeremy Lowe from the Estuary Institute. We met out there to watch this happen live. That's 1.5 feet of water over San Pedro Road, and this is changing those ecotones. This is the big surprise for City of Mill Valley. This is Almonte Boulevard. He's driving on either Almonte Boulevard or Miller Avenue, I'm not sure which. The bay just went up and over the road and extended the salt marsh. They didn't show the photo, but the same thing happened where we got colonization of the landward edges of former terrestrial vegetation began turning to brackish and salt marsh after this event, instantly. Another driver, it's not just about sea level. One of the other drivers of salt marsh diversity change are climate events themselves, extreme weather events. We just came out of one of the most intensive and prolonged droughts in the last, I think, 1,000 years, from 2012 to 2016, varies in different parts of the state. And one of the effects on tidal marshes is that, as I mentioned before, the marsh plain, particularly away from channels where the tides drain salts out, marshes evaporate and concentrate salts. So they naturally become somewhat hypersaline between spring tides that submerge the marsh plain and then drain the excess salts. But in drought periods, the bay itself becomes marine salinity or higher. And so even though all salt marsh plants are somewhat salt tolerant, they vary in their salt tolerance. Pickleweed, perennial pickleweed, is the most salt tolerant species, pretty much, and annual pickleweeds as well. But the others have, their limits. And these, believe it or not, are photographs of gum plant. You can barely see the gum plant. Pickleweed is actually scrambling over it in the left-hand photo, using it sort of as an arbor, which is another story I won't get into, where pickleweed can actually climb and form higher cover by climbing over dead shrubs and provide extra cover for marsh wildlife like rails. But they're not reproducing. And the right side is China Camp Marsh. Those sloughs are normally bordered by extensive and continuous bands of flowering gum plant all summer. And you can see there's a complete brownout in the marsh. And we can expect these events to wear down our populations of not just gum plant, which is a very conspicuous dominant along creeks, but many of the more salt sensitive species, particularly the brackish floras, are going to be lost by attrition unless we incorporate brackish marsh gradients into tidal marsh restoration projects. This also has problems for marsh stability. Bank strength also declines during hypersalinity events. And this is something we have faced before but didn't notice. CNPS, I believe, listed gum plant, Grandilia stricta angustifolia, as a list 4 watch species back in the 70s. And I'm pretty sure it was Phyllis Faber watching, I don't know, but I think she was observing abrupt decline of gum plant after the 1970s drought and saw, wow, they're just disappearing. And I think we've watched this now several times. They don't necessarily disappear all at a time, but she was observing a real phenomenon, I think, these extreme marsh brownouts. So getting back to where we can go through all this, I would point the way that there are 2 topographic directions we can bring our marshes, independent of the amount of sediment available in the bay, independent of the amount of money we have for restoration projects and heroic engineering. One is that valleys that are in low intensity or open space land uses that are adjacent to tidal marshes are probably the single best bet for long-term tidal marsh conservation. That doesn't mean we can't do good things in the meantime and trying to restore traditional tidal marshes, but looking at that 2070 horizon, we not knowing which marshes are going to founder and collapse and turn to mudflats and which will actually maintain that high diversity, not just any kind of salt marsh, we're not just looking at laying salt marsh like carpet, where it's mostly cordgrass and pickleweed and a tiny little edge that houses very few species. But if you want to maintain that diverse upper intertidal zone, you probably need to look at the limited opportunities for tidal marsh transgression over valley lowlands. And even in natural areas where there are terrestrial edges, like these hill slopes, the natural edge is very narrow. It's sort of topography as fate for tidal marshes is I'll suggest that as an important takeaway message. Another land use, and I did kind of sneak in some West Marin advice in this, because West Marin is both an example of where tidal marshes can go, but it also points to another subtle but important potential barrier, not a physical or topographic barrier to tidal marsh transgression, but this is a land use barrier. Here there is, again, open grazing in what is designated wilderness, federal wilderness. I think a lot of CNPS folks maintain, perhaps reasonably, that in general, grazing in pasture land is compatible with conservation of native plant diversity. In many cases, I don't dispute that. But where tidal marshes are, green and palatable, and the uplands around them are desiccated and unproductive and unpalatable because of drought, cattle concentrate their grazing in the moist, seepy edges of terrestrial lowlands and in tidal marsh. Most tidal marsh plants are highly palatable. Any marsh you visit in Wales or Ireland or most of England, they are grazed marshes, and the dominants are grazing tolerant. They're not natural dominants. A lot of species diversity. This is good bird's beak habitat that is grazed down to a turf where there is no bird's beak. It's heavily trampled. The soils are soft and muddy. It's highly disturbed. This is topographically, Point Reyes is one of our best overall refuges for uninterrupted tidal marsh transgression through whatever rate of sea level rise we encounter. But it will depend on grazing management if it's to include the diversity that we want to conserve in those marsh zones. And here's how it can look. That green is green algae from elevated ammonia from urine, from cattle deposition. And the poached ground is, of course, cattle grazing in soft mud. The area behind it is somewhat impounded, but not fully. So again, this is a land use constraint on tidal marsh transgression. And here we are back to Muzzy Marsh, the flagship of the best of 1970s tidal marsh restoration, focused entirely on the vertical accretion of the marsh plane or platform, no consideration to long-term transgression. And this is, again, on a perigee high tide, a king tide, and you can see the entire marsh is almost completely underwater. It actually was an hour later. This is what the high marsh transition zone is. So you can probably leap over it. Urban flood control, steep slope, that is the limited future of Muzzy Marsh, unless you basically re-engineer it for future sea levels, which is, again, expensive, heroic engineering. So I think we need to rethink our portfolio of investments in tidal marsh management and restoration to think not only of what individual projects may yield in the 20 to 30 year range, but thinking way ahead for those extreme rates of sea level rise that we're likely to encounter a few decades ahead, but very foreseeable. I mean, I've been watching tidal marshes for about 5 decades, and I'm not that old yet. We will see these conditions, and we are just now going through some of those extreme climate events as well. So here are my takeaway messages. Sorry to go on so long. I can just flash these by and go to questions. But the first priority I recommend for adapting to sea level rise, again, is to conserve lowland, supratidal, above tide valley space and dedicate it for landward migration of tidal marshes. There are not that many places where this is possible. They need to come to the front, I think, of the conservation planning line. And there's some examples of, these are not big ticket restoration priorities right now, like Belmarine Keys and Hamilton and the old diked Bayland filled basin model. Another emphasis is on making sure you incorporate those wide, high salt marsh gradients in conservation planning, whether it's for restoration or existing tidal marshes. And don't just revegetate them with utility species for wildlife cover alone. Of course, that's an important planning consideration for wildlife, but make sure that you incorporate at least some balance of natural, local, analog plant communities that are suitable for those transition zones, and use local populations. If they've been hanging in refugia for thousands of years, they probably need a leg up to make it to the next 100 years. And you got the message with agricultural landscapes. We need setbacks for cattle grazing lands, so the cattle don't rush to the last productive buffer zone along the back of the tidal marsh. And even though we have a long tradition of preferring passive colonization, natural dispersal for tidal marshes, we know from 40 or 50 years of marsh that even though it's right next door to a prehistoric tidal marsh remnant, it never picked up the rare species, except for the, it didn't pick up bird's beak at all. After 50 years of potential seed dispersal right next door, it did pick up one of the sedges. We probably need to facilitate dispersal of plants that have already become reduced in population size. The Bethune Marsh example with that Pohono Street accidental marsh restoration for bird's beak, I think is a really good example to keep in mind. Small, even degraded small areas can be very important for maintaining high marsh refugia for rare plants. We need to include tidal marsh plant refugia locations, even if they appear to be degraded, even if they appear to be too small for important wildlife areas, include a lot of the legacies of surviving plant populations at tidal marsh edges. And I'll leave the last one. Notice this is down to my lowest priority, even though it is definitely taking the majority of resource agency focus. We do need to augment sediment supplies to tidal marshes artificially. I think that is without question. We can't afford to waste any sediment. We can't dump it in the ocean. We are doing that now because of cost. But at the same time, in our deserved rush to try to deliver as much sediment as possible to marshes to keep their heads above water with rising sea level, remember, if you bury plants too rapidly or expose them to perturbations of flooding too often, you will sort out a lot of the rare plants that don't tolerate those disturbances, like some of the rare annuals. So we need to balance our the locations and the pace of sediment delivery, particularly from flood control channels, to make sure we don't aim a fire hose of sediment right in our sensitive habitats. And if at all possible, distribute them so we have uneven aged deposits of alluvium or floods like Pine Gulch Creek Delta, where the inactive fallow lobes picked up all the diversity and the active lobes sorted out the disturbance tolerant brackish marsh species. So that's it. I've gone over, I'm sure, much beyond my time. Yep.
Peter, I want to thank you so much. It's just profound what you've covered, and you've given us so much to work with, so many tools to think about what we're dealing with in terms of tidal marshes, and it's just amazing. I would call it a paradigm shift, at least in my mind. And I just wanted to, before we start questions, just to let people know that that Peter's Zoom presentation will be on our YouTube site. So if, like me, you would benefit from going through this a second or maybe even a third time, because there was so much there and so profound, it will be there for you to go through at your leisure. Normally we stop at 9, but because of the importance of the topic and how profound the issues are and your construct, I just like to go through the questions and Because I just think we should. So let me just start
Well, I
with,
apologize for the time. That is my fault
well,
entirely, and it's a bad habit.
no apologies. The subject was certainly worth the time. So let me just start with the questions in the chat, and we'll then, I'm gonna open it up so people can unmute themselves when we get through the chat. But let's start with the chat questions. Chia Hamilton asks, how will the West Marin tidal marshes be affected after the elk are eliminated and the cows will be more plentiful and playing havoc with the land? I guess you've covered that. That was one of your final points. Any additional points on that?
Elk are fine. They don't trample like cattle. They range wildly. One of the other missing elements from Point Reyes, of course, is fire. Point Reyes, like most coastal grasslands, excuse me, was burned regularly by coast miwok. So I think of more importance than elk would be fire regimes, and I'm not sure we're about to get close to those, but that would be another aspect of terrestrial vegetation management that would be important for tidal marsh diversity.
Jill Templeton asks, how big is the bird's beak?
Oh, well, it basally branches, so it can get quite wide. A single plant with in a favorable spot without too much competition. They like those openings sort of at the edges of a bare pan and the edge of pickleweed where they can expand and get a lot of light. A single plant can probably get almost a foot wide. That's big. 6 inches would be more normal. They occur in colonies. They can mingle together. It's hard to tell individuals apart. And they're usually much less than a foot tall. Depends on the competition. If they're around taller plants, they will elongate to, close to that height.
Vernon Smith notes that there is a stand of bird's beak at Buck's Landing in Santa Benicia.
Yes, I consider that part of the China camp of, even though actually it is now, I think Marin County now owns Buck's Landing. They did purchase that. I have walked through there. So yeah, I would, even though it's not in the NERP properly, I consider that part of the Galenas Marshes or the China Camp Marshes.
And Jill Templeton asks whether it exists on Aramburu Island.
It did briefly. I haven't been there this year yet. It did colonize. We had it planned to be reintroduced using the Pahono Street population or the Bothine population, but it got there before we did, and then it disappeared, probably because of erosion. So I wouldn't leave it a chance. I think it's worth reintroducing. I think we've been very shy about reintroductions, fearing more harm than good from abuses of compensatory mitigation, which I totally understand as a policy issue, but it's time. It's just time. Again, I'm struck by the fact that Muzzy Marsh, after 50 years, through no fault of its own, just didn't pick up any bird's beak populations. I think that's just a cue that we need to help the seeds disperse. They took, hundreds of years to do that. We don't have hundreds of years if we want the outcome now. We just need to pick up the capsules and move them.
Jude Stalker asks, why is Castanea extirpated in San Francisco Bay?
I've looked at all the localities that David Keck found and earlier ones. Most of them, of course, were just diked out. And again, even more than chloropyrin, Castanea ambigua likes that extreme upper intertidal zone, particularly where there are, I'd say, the equivalent of alkali flats. They like a sort of a pan-like or a scald zone where the competition is reduced and there's a lot of bare spots. And almost all of those historic localities were diked and filled. There's one large remnant population at Point Pinole, but that's an unusual one. It's probably a backcross, stabilized backcross, perhaps a cryptic taxon with Castanea densiflora. And the other population in Benicia is extirpated by erosion. It's a drought story. And there are a few populations in Napa, but they are unstable. And I think they're also in Sassoon, but all the ones I've seen are unstable. They come and go. So mostly the same old story. We diked our edges, and also they're not on anyone's list to be reintroduced. The nearest population we have is Rodeo Lagoon. It's probably the representative of the ones we have in the West Bay, particularly Marin and the peninsula. And it's a very tiny population. I'm not sure it's going to make it. Anyway, it's worth restoring.
Loretta Figueroa asks about Almonte Marsh. Rather than increasing the height of the seasonally flooded roadbed, could the road be replaced by a bridge and the existing roadbed removed?
Yeah, some of the drawings I've seen did have elevated, I think they have plans for elevated bike paths. I don't know about the road. The road is a separate jurisdiction. I think that's entirely Mill Valley. And I don't know that they've actually been, it's odd. We're designing the bike paths and the public access, but not the roads because it's a different jurisdiction. And that's way over my head. But yeah, I think just as a citizen, I would like to see plans for that road be integrated with all the other plans for the city and county. It would make sense to have sort of a summit discussion between city and county about that. But I'm a sub-consultant. That's not what I recommend.
And Ann Libben asks, how does Marsh Transgression interact with Zostera Marina?
Well, it's safely subtidal, and honestly, I think that one is likely to be a huge beneficiary of reduced sediment supply as suspended sediment declines in San Francisco Bay, particularly in areas where there's some sand in the subtidal bed that actually reduces suspended sediment concentrations even further. There's more water clarity and more light transmission. I think, well, I'll defer to Kathy Boyer on this, but I think the recent increases in the range, in at least in Zostra, bodes well. I think also oysters may be a beneficiary of reduced flood sediments, more stable salinities, higher salinities, and more water clarity in San Francisco Bay. The increased water clarity may bring some other changes that may not be so easy to swallow, like more algal production that has been limited by turbidity, by suspended sediment, may interact with nitrogen. But on the whole, it looks like Zostra may have a shot of improved conditions. But I'll defer to Kathy Boyer on that.
That's the extent of the questions in the chat. Peter, why don't you stop sharing your screen so we can see
right
who's on the call. And if anybody has a question,
I need to be illuminated.
would like to ask it in person, I'd encourage you to go to the reactions button and hit the raise hand. If there are no additional questions, I think we've come.
Thanks to anyone who stayed this long.
Yes. I see no additional questions. I would just like to say for next month, we're still, we don't have a definite speaker. We plan to have a speaker on the second Monday of August, and stay tuned for your email. I'd also say that if any of you went onto our website in late afternoon or this evening, it's down. We tried to upgrade a piece of software and it crashed the site. So we're going to get it back up as quickly as we can. But it takes greater expertise than some of our volunteers who are managing the site to do it. So with that, I want to kind of hope that you will join us next month, and thank Peter again for just an amazing talk. And we hope to see you next month. So
thank
good
you.
night.